students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today, I will discuss about the flue gas characteristics and then its treatment. So, flue gas from the burning of an incinerator plant, the gas will come. What are the characteristics of this flue gas and what is the treatment of this flue gas? So, here we are discussing about the transformation of municipal solid waste. So in this section only, we are discussing this flue gas characteristics and its treatment. Flue gas characteristics and its treatment. So this is the point where we will discuss about the gas that will be like coming out from the burning of MSW into an incinerator plant. So this gas will have will contain some of the contaminants, like because we are burning a municipal solid waste, and that those municipal solid waste which are hazardous in nature. So by the burning of these municipal solid waste, the flue gas, the fumes will come. The fumes will consist of many hazardous metals and very contaminants are there in that flue gas. So that's why we are discussing these things, how we'll treat these flue gases in an incinerator plants, and how before opening it into the air, how this treatment should be done, and what are the different devices that are using for the treatment of this flue gas, and what are the characteristics of this flue gas, which type of gases are coming out from this flue gas. So first of all, let's start this topic with what are the combustion products, what the combustible materials into that MSW. So first of all, in the high temperature, what happen? Oxygen surplus present in the combustion chamber. At a high temperature, oxygen are present in the combustion chamber. In all input species are converted into the most chemically stable product under the oxidizing condition. So this is like a in the combustion chamber, the temperature is already high, and we are providing temperature more than 1000 degrees Celsius, and oxygen is also there. So in the presence of oxygen and in the presence of temperature, the combustion chamber and the input species are there, and that have a tendency to convert it into a most chemically stable product. So maybe this will be going to convert into a chemically stable product under an oxidizing condition. So this oxidizing condition is created inside the combustion chamber. So in this oxidizing condition in the combustion chamber, that high temperature and extra oxygen will input into that combustion chamber, and that input will going to convert into a most chemically stable product. So what happen after that? The product is either in a gas phase or remains a solid residue in a fuel bed. So into that fuel chamber, into that chamber, the product is either in the present in the form of a gas chamber, gas phase, or it remains as it is in a solid residue. So the what happened with it? The major environmental issues from the integration of combustion process was the flue gas treatment. This gas treatment is a major environmental issues with that combustion process. Because of this, flue gas will contain many contaminants. Many contaminants are there in that flue gas. So this is the meaning of this starting this combustion product is like the major environmental issues is associated with this flue gas. So that flue gas integration combustion process are there, and this flue gas treatment is required. So this is one of the major environmental issue. And second thing is that why is the solid residue is getting produced after this incineration process. So this in this flue gas characteristics and its a treatment, 2 point is a main point, and that is the point of concern when you talk about the environment point of view. First point is that like that it is like that why this flue gas has been generated and how to treat this gas. So flue gas treatment, and secondary, why is solid residue is getting produced after the incineration process. So this all will study about the combustion product. Combustion at a very high temperature. Already we are providing temperature more than 1000 degrees Celsius in the presence of oxygen also. So many reactions are taking places in this solid waste, because MSW is there, and that too are some hazardous waste are there. So their reaction can take place, many reactions can take place. So first of all, what happened? mineral material are there. So mineral material are there in that combustion product. So this is a picturization of combustion product. So combustion product is having four wings. First is like mineral materials, halogens are there, volatile heavy metals are there, carbon, hydrogen, sulfur and nitrogens are there. So first we'll talk about the mineral materials. So mineral material is also as well as lithophilic heavy metals. Litho means what? Litho means soil. Litho is equal to soil. So those things, that is lithophilic, means that is loving. Philic is like loving. So loving or though associated with soil, those things that is associated with soil, those things that is associated with soil is called as lithophilic heavy metal. So those metal which remains with the soil materials is called as lithophilic heavy materials. And the iron, some of the percentages of iron, manganese, titanium, nickel and their compounds leaves the combustion chamber as bottom ash at the back end of the grate. So these some iron is there, iron, manganese, titanium, nickel and their compounds will leave the combustion chamber as bottom ash at the back end of the grate. And the trace of product of incomplete combustion, means those product which will be left by the incomplete combustion are found in the bottom ash, and that bottom ash we can say it as like a fly ash. And this type of thing like the trace of product of incomplete combustion is also found in the bottom of the ash. So see, this is a picture of a combustion product. So combustion product will burn, the combustible material will burn, and first it will make mineral materials, then halogens, sometimes volatile heavy metals, sometimes carbon, hydrogen, sulfur and nitrogen. So four wings are there. So what happened, these mineral materials are like lithophilic heavy metals, and it includes iron, manganese, titanium, nickel and their compounds, and these compounds leave the combustion chamber as bottom ash at the back end of the grate. And the trace of products of incomplete combustion are sometimes also found in the bottom ash, and that can be termed as a fly ash. And next is like what happened after this mineral material formation. Next is the carbon, hydrogen, sulfur and nitrogen formation. So how this formation takes place, it is like first of all, stable oxidation product of all carbon compound is CO2. CO2 is a stable oxidation product of all carbon compounds. So CO2 is present in the form of gaseous phase. Hydrogen is always oxidized to H2O. Now what happened, this hydrogen is also present, it will oxidize to H2O because of the presence of oxygen. Oxygen is already there, we are providing very high temperature and with oxygen also. Sulfur is already there in the waste, so sulfur form both the gaseous SO2, sulfur will form gaseous SO2 and solid sulfate that remains in the bottom ash. Nitrogen is partially oxidized to NO with a small amount of other oxide like NO2 or N2O. So nitrogen is N2 is partially oxidized to NO. What happened with it? Sometime it will make NO2 or N2 or N2. And depending on the operation mode, more or less particulate matters leaves the furnace as dust in the flue gas. So depends upon the operation mode, means what the operation mode is there. So on that basis, some more or less some particulate matters are there. That particulate matters leaves the furnace as dust, fly ash in the flue gases. So this is first in the combustion product. 4 points are there, they will form four type of material. First is like mineral material. So mineral material is called as lithophilic material, means those which is associated with the soil, those which is bonded with the soil. Then first is the mineral material will be formed. Next is like some gaseous substance will be formed because already more amount of oxygen is there. So in the presence of oxygen, this combustible material will form a reaction, and that is called as carbon, hydrogen, sulfur and nitrogen. Next is like volatile heavy metals. Volatile heavy metal will also form, and sometimes halogen will also form. Halogen are the inert gases. So these four wings are there with this combustible product inside an incinerator. Inside incinerator, these four will be formed, and the mineral material carbon, hydrogen, sulfur, and nitrogen, volatile heavy metals, and halogen. So depending upon the operation mode of the incinerator, the particulate material like is PM leaves the furnace as like of dust in the flue gases, and dust is what it is a in the some fly ash is there. So fly ash is already a dust. So depending on the operation mode of that particular incinerator, some particulate matter will become, sometime dust will become, and dust is called as solid residue. So solid residue means the fly ash. Now comes to the next point that we'll talk about the incomplete combustion. What sometimes incomplete combustion is also there. So due to incomplete combustion of carbon, that leads to the formation of carbon monoxide and TOC. These two are very dangerous and harmful gas. Like PAH will also form polyaromatic hydrocarbons and soot particles. All these are very dangerous substances, and that is going to pollute the environment. So, due to incomplete combustion of these materials, solid residue, incomplete combustion will lead to the formation of carbon monoxide, total organic carbon, TOC, sometimes PAH, polyaromatic hydrocarbons, and some soot particles. And these soot particles are known to be the source of toxic low volatility halogenated organic micropollutant, especially PCDD and F. So this is soot particles, this because these soot particles are very small particulate matters. So these soot particles will form sources of some toxic low volatility halogenated organic micropollutant. Low volatility halogenated organic micropollutant, and especially like PCDD and F. These soot particles are known to be a source of toxic low volatile halogen light organic micropollutant, especially PCD. So these pollutants are very toxic pollutant and low volatile also. Halogens light organic micropollutants, especially PCD. Soot particles are small particles, and they are known to form some toxic substances. Toxic means leads to the low volatile material and halogens. So these are called as some days toxic particles that will coming out from the flue gases by the burning of some due to incomplete combustion. Due to incomplete combustion, this will lead, like some small particles are there that will change into a low volatile hydrogen like carbon monoxide, TOC, or sometimes it is very dangerous PAH, and soot particles are there. Next is like halogens. Halogens will also form due to this burning, and halogens can be transported into their respectively halides. Respective halides are there. So hydrogen is like chlorine atom is like that. So chlorine will form with H2O and H, and then they will form HCl. HCl is a hydrochloric acid. Hydrochloric acid is a very dangerous acid. Hydrochloric acid, this is only responsible for the acid rain. This hydrochloric acid is responsible for the acid rain. So chlorine is the major product, is a gaseous HCl, and 10 to 15% of the chloride stay as a metal chloride in the solid residue. 10 to 15% of the chloride stay as like a metal chloride in the solid residue. Bromine is also there. Bromine is also an halogen, and it is almost like it will be equal to a HBr, and metal bromide are formed. So with these things, they can form many toxic metals. And next is the fluorine. So approximately like 70 to 80% is found in the fluorides in the solid. So fluorine is like 70 to 80%, it can found in the fluorides in the solids. Okay, 70 to 80% of basically fluorine are there. So with this flue gases, halogens is also a very important point. So halogen will consist of chlorine, bromine, and fluorine. Chlorine will make with reaction with H2O, it will make a HCl. HCl is a very dangerous hydrochloric acid. So, and 10 to 15% of the chloride stay as metal chloride in the solid residue. Next, bromine is there, and fluorine is there. So bromine is like almost equal to HBr and metal bromides, and it will be formed. And fluorine is like approximately 70 to 80% is found as fluorides in the solids. And now comes to the next point, that is like volatile heavy metals. So volatile heavy metals are those metals that mainly evaporated as chlorides in the furnace. Mainly by the evaporation, it will be formed a chloride. They are called as the volatile heavy metals. And the next is like the more than 80% of the content of the mercury and cadmium in the solid waste leaves the combustion chamber in the flue gas. Means mostly 80% of the total mercury and cadmium heavy metals will leaves in the flue gas and when they are leaving the chamber. And 30 to 50% of the zinc, 30 to 50% of the zinc, arsenic, antimony and lead is evaporated in the combustion chamber and transferred to the raw gas. At the typical boiler outlet, temperature is 180 to 200 degrees Celsius. All volatile heavy metal species except mercury and its compound are bounded to particulate matters and are removed along with the dust in boilers and filter ashes. So, these volatile heavy metals are again a very dangerous metal, and they are mainly evaporated as a chloride in the furnace, and the more than 80% of the content of mercury and cadmium in the waste leaves the combustion chamber in the flue gas. 80% of the content of mercury and cadmium in the waste leaves the combustion chamber in the flue gases. 30 to 50% of the zinc, arsenic, antimony and lead is evaporated in the combustion chamber and transferred to the raw gas. At the typical boiler outlet temperature of 180 to 200 degrees Celsius. 180 to 200 degrees Celsius, all volatile heavy metal species, except some of the mercury and its compound, are bound to particulate matter, and then it will be removed along with the dust in boilers and some filter ashes. So the bound to particulate matters, this typical boiler outlet is there. It is up to 180 to 200 degrees Celsius, and all the volatile heavy metal species are there except some of the mercury and the compound of the mercury. It is bounded to a particulate matter. It will be bounded to particulate matter and are removed along with the dust in boiler and filter ashes. So this is about the volatile heavy metals in the incinerated chamber. Next, what happened with the flue gas? Flue gas is like that is coming out from the stack, and the flue gas is 80% of the waste is transferred into the flue gas during the waste incinerated process. So mostly 80% of the waste is transferred to the flue gas during the waste incineration process. Most problematic components in the flue gas are like some dust particles, some acidic gases. Acidic gases is like hydrochloric acid, HF, SO2, NOx, and heavy metals and organic pollutants. Most problematic components in the flue gas are dust particles, smaller dust particles. Flue gas must be extensively cleaned before being released to the atmosphere to the stack of the plant. So flue gas must be extensively cleaned before being released to the atmosphere through the stack of the plant. About 80% of the waste is transferred into the flue gas during the waste incinerator process. 80% will transfer to the flue gas during whole incineration process. And next, what happened? The problematic components are there in the flue gas are some dust particles, some acidic gases, and NOx, heavy metals, and organic pollutants. Flue gas must be extensively cleaned before being released to the atmosphere through the stack of the plant. So it must be extensively cleaned. This flue gas must be cleaned before it is releasing to the atmosphere by the stack of the plant. So this is the description about the flue gas that has been taken place during the incinerator process, whole incinerator process. And this flue gas is like most of the 80% of the waste is transferred to the flue gas. While converting that hazardous substance into a non-hazardous substance, 80% of the contaminants will be transferred into the flue gas during the waste incinerator process. And the most problematic thing in the flue gas are like some dust particles. The most problematic component in the flue gas are like some smaller dust particle, some acidic gases are there, and NOx, heavy metal, and organic pollutants are there. And the flue gas must be extensively cleaned. This should be extensively cleaned before releasing to the atmosphere, to the stack of the plant. That's why some of the air purification device has been installed into the incinerator plant. So it should be cleaned, because all the contaminants, whatever the contaminants is there in the air, it will be consist in the flue gas. That's why the flue gas treatment before dispersing it into the atmosphere is very important. And now we'll discuss what are the devices that has been installed for cleaning of this flue gas into the incinerator. So their dispersion, their leaving into the atmosphere is very toxic, very important, because they will consist all problematic components like the flue gas, or some smaller dust particles, some acidic gases, some NOx, some heavy metals, and some organic pollutants also. And it should be cleaned, it must be cleaned before releasing it into the atmosphere by the stack of the plant. This is the data for the flue gas dispersion. Flue gas dispersion, whatever the standard has been maintained for this flue gas dispersion into the atmosphere, flue gas releasing into the atmosphere. So for this concentration is like for dust, for HCl, SO2, NO2, carbon monoxide, mercury and its a compound, PCDD and F. So their concentration is like, if dust particles are there and they have been concentration is in the range of 1000 to 5000, and their mass flow is in the kg per temperature, and then EU standard, American standard, and then Indian standard. You use a European Union, American, and then Indian standard. So as per the European Union, they are allowing only 10 mg per meter cube of dust. American is also more, 54%, and Indian is quite less, that is 50 only. Next is the HCl. HCl mass flow is just like 6.5. So EU, as per European standard, they are allowing it up to 10%, their permissible limit. 72 is the American standard, and 50 is the Indian standard. Again, if we talk about the SO2, sulfur oxide, SO2, like then SO2 is there only 2 is in mass flow. If it will becomes under the mass flow, it is the concentration range is 150 to 400 degrees Celsius, and 50, and American Union standard is 41, and Indian standard is to 200 mg per meter cube. Like that, NO2 is also there. So NO2 is like 3 mass flow is there, 200 EU standards, and American standard is 569. Then again, Indian standard is 400 mg per meter cube. Carbon monoxide is also there. So in carbon monoxide, zero point 0.1 mass flow, 50 is the EU standard, American standard is the 140 mg per meter cube, Indian standard is the 100 mg per meter cube. Like that, mercury and its compounds, that is again very less, that is 0.002, and here EU standard is 0.05, 0.05. 0.36 is the American standard, and 0.05 is like Indian standard. For this also, in case of PCDD and F, it is like a 0.5 to 5 ng per, and less than 5 microgram per ton. For EU standard, 0.01 ng per meter cube. For American standard, 0.31 ng per meter cube. Indian standard, 0.1 ng per meter cube. So this is the flue gas releasing standards, whatever is followed by the either from European Union, or from American standard, or from Indian standard. Now, flue gas cleaning system. How this flue gas cleaning system will be adopted? So this flue gas cleaning system is required to reduce the concentration of specific pollutants to concentration well below the respective air emission limit. And the flue gas cleaning system is required to reduce the concentration of specific pollutants to concentration well below the respective air emission limit. So 4 specific type of pollutant are cleaned. Basically 4 type of pollution should be cleaned. First one is the dust, and dust will go like fly ash, then acid gases, PCDD, then NOx. Okay, four specific type of pollutants are there that should be cleaned, and the flue gas must be extensively cleaned before being released to the atmosphere through the stack of the plant, because flue gas will have 80% of contaminants will present in the flue gas, so that it should be extensively, it should be thoroughly cleaned before it will be released into the atmosphere from the stack of the plant. So, and there are four type of pollutants are there that should be cleaned before releasing it into the atmosphere. So first is like dust, then acid gas, then PCDD, and then NOx. So specifically, four pollutants are there that should be cleaned before releasing it into the atmosphere through the stack of the plant. Now comes to the induced drought fan. So first of all, a fan has been installed that is called as induced drought fan, ID fan. So key component in the this is the main component in the flue gas treatment plant. This should be installed and as a main component into the flue gas treatment plant, and it will ensure that the transport of flue gas from the furnace through all the processes steps of the flue gas treatment plant to the stack. It ensures the transport of flue gases from the furnace through all the processes, and it will steps of the flue gas treatment plant to the stack. It is located in the back end of the process train. The ID fan, induced drought fan, also ensures that no polluted flue gas escape from the process equipment by providing a reduced pressure into it. So located in the back end of the process train, the ID fan also ensures that no polluted flue gas escape from the process equipment by providing a reduced pressure into it. And the flue gas transport is quite demanding in terms of power consumption, and the ID fan in the largest single power consumers in the entire waste incinerator plant. So this flue gas treatment is like quite demanding in terms of power consumption, and the ID fan is the largest single power consumer in the entire waste incinerator plant, and it is located in the back end of the process train. The ID fan also ensures that no polluted flue gas escape from the process equipment by providing a reduced pressure into it. So this ID fan, induced drought fan, is the main components in the flue gas treatment plant, because it ensures the transport of flue gases through the furnace through all the process steps of the flue gas treatment in the plant to the stack. All pre-treatment from the flue gas to the treatment plants to the stack, and the located, it will be mostly located in the back end of the process train. And the ID fan also ensures that the no polluted flue gas escapes, no any polluted flue gas should be escaped from the process equipments by providing a reduced pressure into it, Flue gas transport is quite demanding in terms of power consumption. Flue gas transport is quite demanding in terms of power consumption, and the ID fan is the largest single power consumer in the entire waste incinerator plant. So next is like some devices there. That device is used for the dust removal. So for the dust removal of this from the flue gas, the cyclone is there. Cyclone precipitator is there. So in cyclone, it will works on the inertial impaction of fly ash separation. So it will work on the inertial impaction of fly ash separation. The gas enters a cylindrical chamber tangentially at a high velocity. Thus, the forced into a cylindrical path, the gas enters a cylindrical chamber that tangentially at a high velocity and thus forced into a cylindrical path. The centrifugal force acting on the particles, the centrifugal force that is acting on the particles causes them to collide with the walls, where they impinge and settle out down into the discharge hopper. So the centrifugal force is there, that force acting on the particles and causing them to collide with the walls, and causes it to collide with the walls where they impinge and settle down into the discharge hopper. The clear gas is extracted through a central tube. The clear gas is then extracted through a central tube. So this is the raw gas will come from here, and fly gas will be collected here. collected here, and the clean gas will be passed out. This will be the clean gas will be passed out from this opening. And the its removal efficiency is like 50 to 90%. And it can be operate in the temperature of 850 degrees Celsius. So this is the basic description about this cyclone precipitator. This cyclone precipitator is has been installed to basically to filter out the fly ash separation, and then flow gas will enters into a cylindrical chamber. Then tangentially it will, with a very high velocity, it has been forced into the cylindrical path. The centrifugal force, which is acting on the particles, causes them to collide with the walls, where they impinge and settle down into the discharge hopper. The clear gas is then extracted through the central tube, and its removal efficiency is 50 to 90%. Operating temperature is up to 850 degrees Celsius. Next device is there, that is called as ESP, electrostatic precipitator. So what is this? It is like an electrical field is there. It has been established between the grounded metal plate and the central wires, which are negatively charged to 300 to 100 kV by rectifier, 30 to 100 kV by rectified AC power. The flue gases passes the aisle between the plates at a very low velocity, that is 0.5 to 1.5 meter per second. The fly ash particles are ionized by the corona discharge and start to move along the lines of the electric field until they impinge upon the plates. The fly ash particles are then ionized by the corona discharge, and it started migrating along the lines of the electric field. It will start migrating along the lines of the electric field until they impinge upon the plates, until it will impinge upon the plates. So at certain times the deposited particles are removed from the plates by wrapping. At a certain time, the deposited particles are removed from the plates by wrapping, by some mechanical vibration of the plate, and collected in the discharge hopper. In this way, the dust particle will be collected. Dust particle is collected on the hopper. And certain times the deposited particles are removed from the plate by wrapping, some mechanical vibration of the plate, and collected in the discharge hopper. Now let's discuss about this efficiency. If we talk about the removal efficiency of this electrostatic precipitate, it is more than 1995, and its temperature is like 400 degrees Celsius. So this is the actual picture of this electrostatic precipitator, where you can see some raw gas will come, and the dust collection plates are there, and high voltage wires for corona discharge are there, and then corona discharge along the length of the wire. Then clean gases will be come out from here. This wrapping device are there. With the wrapping the devices, the dust will be collected on the plates, and dust removed from the plates. Then dust can be removed from the plates to the hopper. This is the picture of an electrostatic precipitator that has been basically installed to collect the dust particle like fly ash. So these are some of the references of the some of the textbook that you can follow, that if you want to in-depth study, more study about all these things, you can follow this textbook that you can use, that will help you in taking you in-depth knowledge of this all these types. And now I'm concluding my lecture. So as I have discussed about the flue gas characteristics and the treatment of flue gas before it's leaving into the atmosphere, before it passing through the stack. So for this treatment, because this flue gas are very dangerous, because in the flue gas, in the incineration process, the incinerator is taking at a very high temperature and in the presence of oxygen, so it will starts burning at a very high temperature. So by the burning of fossil fuel, fumes will be generated, and that fumes is a very dangerous, because it will contain some halogens, chlorine, some bromide, and some of the toxic heavy metals also. That's why the treatment of this flue gas is important. So for the treatment of this flue gas, electrostatic precipitator cyclone separators has been installed in the incinerator chambers or so that it will be filtered, and the bottom it will be the fly ash or the solid residue, whatever the combustion left out combustion product are there, that will be collected and that will be not dispersed directly into the atmosphere. Though so that's why this is important. So if you have any question, if you have any query, you can write in the comment box, or you can directly mail me on the my given mail id, that is shikha.pandy @gmail.com, or you can mail me also. For thank you for today's lecture.
Like, share, and subscribe. Hit the bell icon for more updates.